All right, kiddos, we're taping you today. No pressure. Just kidding. A little bit of pressure. Question. Focus on it. You guys have a little bit of time to talk it out. Time to focus on it. Why did I write f prime of x equals? Why am I doing that? Finding the derivative of f because what does the formula say? Focus. F inverse prime of a is 1 over f prime of b. F prime of b. So I want to take f. In the beginning of homework number 3, it's easy. There's a video on it. Switch x and y, solve for y. He's the inverse. Take the derivative, plug in the x, you're done. But the struggle is, guys, if you try to switch x and y on this one, can you solve for y by himself? So since you can't solve for y by himself, we have to have another way. And the other way, the way out is the formula. F inverse prime of a is equal to 1 over f prime of b. So f prime, what did you guys get? 3x squared plus 2e to the x. Good. So in my formula, it's going to be 3 somebody squared plus 2e to the somebody. Now, who is that somebody? Not 2. For sake of everyone understanding, just tell me not 2. He does not get plugged in our formula. F inverse prime of a is equal to 1 over f prime of b. I need, remember what we were doing in class? I need to realize that a is an x of the inverse, right? A is an x of the inverse, which means he's a who of the original? He's a y. What do I need? The y of the inverse to plug in, which I will get from solving for the x of the original. So we can plug in. Look, we have the original. We don't know the inverse. We can't find the inverse. It's too hard to switch x and y and solve for y. But if I plug in 2 as the y value, well, if you can't solve for y, you can't solve for x, right? Uh-oh. Give high fives in your group. People are falling asleep. Oh, no. Okay, bring it back. How do you solve for x? You don't. Remember yesterday? All like, your face is, okay, focus. Focus. Your face has got all contorted because I'm like, you can't solve for it. And you're like, oh, it's a math class. Of course we know. So I said, AP trick. Now you could graph both and find the intersection, or you can move the 2 and find the 0. But what if you don't have your calculator? The AP has given you one that has a nice answer. A nice small answer. So I said start with 0. Plug in. Really? We're testing? Really testing. Plug in 0. Plug in 1. Plug in 2. Plug in 3. Nothing's working. -1, -2, -3. Something will work. And some of you have already realized 0 cubed is 0. Plus 2e to the 0. Anything to the 0 power is 1. And 1 times 2 is 2. And if you notice, if it was a 1 or a 2 or a 3 or a -1, there would be e's. It's not going to work out so hot. So if x is equal to 0, what can I do? Ah, there's my b. Look, I see him. Plug him in, plug him in. Plug in the 0. Plug in the 0. Solve. 1 over f prime of, not 2. 2 is the y value of the original that we plug and chug. So then, solving. Some certificate or something. No idea. Equals 0 squared is 0. 0 times 3 is 0. 2e to the 0. That's 1. Dun, 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 dun. Remember, that's 0, and e to the 0 is 1. 0 plus plus 2 times 1 is... Does that make sense? Now wait, focus. There is another way of looking at it when there is a function, and that other way of looking at it is called using implicit, which means take him, switch the x and y. Take him, switch the x and y. While I get this up, Chris, go ahead and ask your question. You can't solve for it. You have to test for it. And my hint is, always start at 0. It's going to be a nice small number. Start at 0, plug in. And if it didn't work, plug in 1. Okay, so it's literally a testing and experimenting. I'm going to find it if I just use my little nice numbers. Is that cool? Okay. I'm switching my x and y. Implicit, and Noah, this might help with the idea of what we're doing. Implicit says switch the x and y, and this represents the inverse. I can't get y alone, so I can't make it look pretty, but it represents the inverse. The x's and y's are switched. Now, if we derive using implicit, so the x's and y's are switched. This is an inverse relation. I can't get y by itself, so I can't make it look like a pretty f inverse of x equals. But I do have them switched. The derivative of x is 1. The derivative on the other side. Now, can you guys be amazing? Can I make that same shortcut I did yesterday? They both have a dy dx, and I pull them out. Are you following? He has a dy dx, 3y squared dy dx. He has a dy dx, 2e to the y dy dx. Pull it out from both. Then I solve dy dx, which represents the derivative of f inverse of x, because with the x's and y's switched, that is the inverse. It's just ugly because we can't get y by itself. The derivative is 1 over 3y squared plus 2e to the y. Now hold on. We want to plug in to that y spot. How are we going to do that? We know A, right? If this is the inverse, if this represents the inverse, which it does, we know the inverse has an x value of 2. But where or how do I plug in y? That's an x of the inverse. I need the y of the inverse. Who's the y of the inverse? B. Where do I plug the x of the inverse into? Right there. And I say, okay, 2 is equal to y cubed plus 2e to the y. Does that look familiar? Yeah. So the only difference with doing it implicitly is you see the function with the x's and y's switched. You plug in the x of the inverse where the x of the inverse should go. You solve for the y. I can't solve. Exactly. Chris, so we start plugging in 0. 0 ends up working, so I say, yay, y is 0, so I plug in 0. 0, it's the exact same thing. And it requires the exact same procedure. Kyle.
Will there be a time where using this and then the number with the plugin is like a ugly decimal?
If it did happen, it would be a calculator problem. So if it wasn't one of the nice quick numbers you plugged in, you'd have your grapher, you could just graph it. Graph one side, graph the other side, find the intersection, and you'd be fine. But on the AP, it'll always be a nice number because all the ones that I have ever seen are multiple choice, non-calculator, meaning it had to be a nice small little number. Does that make sense? Now, with this, I'm going to show you guys real quick what a multiple choice problem from the AP guys might look like. Because right now, you just saw using the formula and using implicit. So you might be like, I'm just going to use implicit. And maybe you're like, forget it, I'm just going to use the formula. However, let me show you a sample multiple choice, okay? So APNC practice, just on 2-6, just leave it in your notes. Could say, find F inverse prime of 3 given for 4. People use 4. given f prime of 3 equals 2, f prime of 5 equals 7, and f inverse of 3, actually I won't put parentheses there. F inverse of 3 is equal to 5. And their answers would be something to the effect of 2, 1/2, 1/7, 7, 5. Maybe they would have better multiple choice answers, but those would pretty much be the ones that they would give you. Okay. What's the problem? Why can't we do implicit? We don't have a function. Oh.
B.
Don't look at any of those. Whenever they give you clues, and you guys have seen it in homework tables, whenever they give you little like, hey, this is something, find this. Always figure out the rule first. You have to have something to plug your clues into, otherwise they are meaningless. Okay, you have to have an application, you have to have a place for the clues, otherwise you don't know what's going on, you're going to guess wrong. Question. According to the formula, how do we find f inverse prime of 3? 1 over f prime of b, not 3. 1 over f prime of b, not 3. Hold on, wait. That thing in our notes says given f of x and given and point AB. Who's our point AB? If we don't have a function, we can't find B. Look at your clues now. For the inverse, what point did they give us? 3. What point did they give us? What x, y did they give us? They had to give us a y or else we can't do it. F inverse of x is y? Right? F of x is y. So F inverse of x is a y value. So when x is 3, y is 5. Look, they gave me a and b. I don't have to do anything but know how to plug it in. They gave us the point. They gave us the AB. All we have to do is figure out how to use it. Our little formula says, so we plug in the B, plug in the y value of the inverse, which is 1 over f prime of 5. And who is f prime of 5? 7. Final answer is C. But guess how many kids miss this problem?
All of them.
A lot. No. But a high percentage. It's definitely a commonly missed problem every year. Unless you know how the formula works. For f prime, I need an f prime x, which is a y of the inverse. If you don't know how to plug in, or if you just randomly say numbers, I'm going to do stuff with them, yeah, that's a bad idea. No one go ahead.
Isn't f prime of 3 equals 2 an unnecessary clue? Isn't f prime of 3 equals 2?
But I'm not doing 3.
No.
Remember, we're not allowed to use a 3.
No, on the clues.
Oh, is it unnecessary? Yeah. Why they give it to you? To trick you. They gave you an extra piece just in case you were like, oh, it's a 3. Yay. You know some knowledge, but not enough to get you all the way there. You know them. They're tricky, right? They're trying to trick you. They're going to put the easily missed things, the common mistakes, as answers. That's how they make sure you have full understanding. All right, do we have it? So between these two, what do you think I'm going to suggest? Knowing where you're going,
Formula.
I'm going to say the formula. So can we go back to that part in our notes where we wrote a nice little summary of the formula? Hey, look, did you see how I wrote it too? F inverse of A is B. I think I'm preparing you for a certain multiple choice type problem. I need you to draw a box and make him forever number 16. This is the first forever? Oh my goodness. Right? Because didn't we end at forever number 15 at the end of chapter 2, right? We covered like, I guess it's only a section and a half, but still. And only one forever. Chris. Do you need it?
Yes.
Do you want alcohol wipe? Okay. No because it's going to hurt, or no because you don't need it?
I think I need it.
I'll bring you one.
Okay,
Just in
so
case.
yes. I remember I need it.
Do you need a biohazard bag? No. Gloves? No. Does he put our face mask? Just kidding, they don't give us those. All right, kiddos. We are going into 2-6B. And the very first page of notes is the least, is the worst as far as writing. So I just need you guys to get going and get started because we have to do pre-cal review of struggle. But listen, I just said the first page is the worst. It gets better after that. So go ahead and quickly sketch. You don't have to spend tons of time on it. Sine starts in the middle. Cosine starts at the top. Tangent has vertical asymptotes at negative pi over 2, pi over 2. If you want to, put cosecant bouncing off and secant bouncing off and cotangent, he doesn't bounce off. But I'm just showing you these graphs really quickly so that we can remember the restrictions of sine inverse, the restrictions of cosine inverse, the restrictions of tangent inverse for domains and ranges. That is the big reason why I'm showing you the pre-cal stuff here. You have the most important ones already in your basic graphs. I think that's tangent inverse. He's like the main one. To not forget what he looks like, I'm only going to graph him out of all of these. He's this the one. And he has horizontal asymptotes at negative pi over 2 and pi over 2. Out of all of them, he's the only graph of an inverse that you need to know what he looks like. Everything else is just a quick, that's not a negative number. Everything else is just to help us fill in these domains and ranges real quick. And f of x equals. So don't agonize on these graphs. We don't have time for it. We have better stuff to do. But I'm going to use these graphs. Let me give you a second. Maybe a whole minute. If you really, really want, you can just be like, forget it, I'm going to print it out and cut it and put it on the paper. That's fine. Just a quick sketch. Sine starts in the middle, cosine starts at the top. Tangent straddles the origin. Asymptotes at negative pi over 2 pi over 2. Cosecant bounces off of sine, secant bounces off of cosine. Cotangent, well, it's a little fun. As you guys are writing, I'm just quickly sectioning off these graphs for a very particular purpose. Because in order for these graphs to have inverses that are functions, they have to pass the horizontal line test, all pre-cal stuff. horizontal line test, and they don't naturally, so we have to cut them down. Which is why when you saw sine inverse, cosine inverse, tangent inverse last year, we only looked for one answer, the principal value. We didn't look for all the possible. I won't even worry about the last three. We're actually going to use the first three to be able to get the last three, so I won't sketch anything on those. The domain of the inverse is the same thing as the range of the original, which is just going to be in between 1 and negative. Ooh, its y's of the original, but they're x's of the inverse. The only things that can go into sine inverse and actually get an answer are all the values in between negative 1 and 1. Cosine inverse is the exact same because he has the exact same highs and lows of the original, so he has the exact same domain restriction of the inverse. Anything outside of that you guys saw last year, your calculator would say undefined because you were trying to plug in like a 2 or something, and it doesn't work. Range. Sine, in order to make it past the horizontal line test, we cut it at negative pi over 2 and we cut it at pi over 2. And if you guys kind of can remember from last year, sine inverse, we would only look in the fourth quadrant down to negative pi over 2 and in the first quadrant up to positive pi over 2. We'd only look in the quadrants 1 and 4, up 90, down 90 for answers, and that's it. Cosine inverse. In order for him to pass, he has to go to the right. He's only allowed to be between 0 and pi. He was the first quadrant and the second quadrant only. Tangent inverse is a different deal. Because as you notice, from tangent inverse's graph, which we put in our forever card, he can go forever right, forever left. His domain is all real numbers. He's not restricted like cosine inverse and sine inverse. However, he can only go so high, so low, because there are these vertical asymptotes of the original, meaning horizontal asymptotes of the inverse. He follows sine's pattern, but he's not allowed to be at negative pi over 2 or pi over 2, hence why there are parentheses, not brackets. Brackets mean including, parentheses mean excluding. And I'm just going to use that to fill in down here. Let me go ahead and zoom in on the bottom. This is getting a little rough, I know. Cosecant inverse. He's the reciprocal of sine. He bounces off. So instead of going in between 1 and negative 1, for sake of speed and simplicity, I'm going to say he's everything greater than or equal to 1, or everything less than or equal to negative 1. He's allowed to be anywhere but in between 1 and negative 1. Same thing with secant inverse, the reciprocal of cosine.
Is there like a u function for that?
Well, I could do the whole union, negative infinity to negative 1, u, 1, but just for sake of simplicity. X greater than or equal to 1, or x less than or equal to negative 1, but yeah, no, u means u or. And range, coming from the domain, cosecant inverse follows sine inverse's lead, except it's allowed to be at negative pi over 2, but there is a vertical asymptote in between at 0. Here's the u. So it still goes in between negative pi over 2 and pi over 2, but it can't be at 0 because it has a vertical asymptote there. And for secant inverse, it follows cosine inverse, the 0 to pi, but there's a vertical asymptote halfway in between at pi over 2. Have to cut it up. Cotangent inverse, he's just like tangent in that he can go on forever. His would look, I don't want to make it in blue, it's not as important. But his would look something like that. Cotangent can go forever right, forever left, so we'll say x is all real numbers, negative infinity to infinity. just like tangent inverse, except his asymptotes, his vertical asymptotes were different, so he's going to have different restrictions here. Instead of being in between negative pi over 2 and pi, he's going to be between 0 and pi. Not including because he has vertical asymptotes. Now, this page is not the focus of 2.6b. It is an intro and it's a reminder of the inverse trig functions and how they're being cut down in order to be actual functions. Okay? So don't go crazy studying this page. It's a quick reminder of where we get answers when we have things plugged into inverse trig functions, because every now and then, just like we need the unit circle, if they want a derivative of sine at pi over 3, you need to be able to take the derivative, plug in pi over 3, go to your unit circle, and have an answer. Kind of the same thing on this page. If they wanted you to somehow plug in sine inverse of 1/2, you would need to be able to do that. But this is not the focus. Okay? Let's go to easier review. If you need to skip a few lines, get to it later over the weekend, in the notes, etc. Okay. Easier pre-cal review. Praise the Lord, right? Easier. Easier pre-cal review. If I'm given a regular old trig function, do you guys remember who gets plugged into trig? What do we put into a trig function? What do we take trig of? An angle. Technically last year in degrees or radians, but this year calculus only, radians. Basically he's dimensionless, which means he works for any units. Degrees we have to do all sorts of stuff to make them right. Radians are best. We plug in an angle and we get out what? Why am I saying ratio? Who is sine equal to? Opposite over hypotenuse. It's just a ratio of sides, right? So we plug in an angle and we get out a ratio of the opposite side over the hypotenuse side, which can be 1/2 or 3 over 2 or 2 over 2, 0, 1. Positives or negatives of all of them. Except for 0, that's a little bit trivial. And infinitely many more between 1 and -1. So what changes for inverse? I know I didn't show the whole like switch x and y, solve for y by finding the inverse, etc., etc. But let's just say we're given an inverse. That is our beginning function. Everything has been switched. So who's coming in now? The ratio. Does that make sense? It's been switched. The ratio, so the opposite over hypotenuse. The 1/2 is being put in. The root 3 over 2 is being put in. The negative root 2 over 2 is being put in. And what are you supposed to answer as what's coming out? Now one quick thing on this page. Arc sine, the AP can use to mean sine inverse. Or sine inverse, the AP can use to mean sine inverse. They can use either one interchangeably. At the beginning of the AP, there's a little page that says arc sine and sine inverse are the same thing, basically. So we're going to use them interchangeably as well so that you're just as familiar with either. They're the same thing. He has more letters and not a -1. Whatever. Okay? So the same thing goes for him as goes for him. Long story short, if you're given a sine, cosine, tangent value for inverse trig, value, a ratio of sides. If you're given what sine, cosine, tangent equals, then you need to be finding an angle measure. Inverse trig goes backwards. Your answers are angles. Your inputs are ratios. Okay, that was just pre-cal. Algebra 2 pre-cal. Geometry, I guess.
Is that ratio or ratio?
Ratio. Struggle. The judgment. Ratio. A little bit longer. Almost? How about now? Close. Okay, peek on the people in your group. They probably got it. We have time. So, pre-cal. You can put your pencils down if you don't want to write it. I don't mind. Give them a rest. Let's just think together. In order to solve, how would we undo tangent? Tangent inverse. And if we do tangent inverse of both sides. And if we solve, theta equals tangent inverse of -1. We have to look at that -1 and say, oh, stink, you're a tangent, but where are you in the unit circle? We're not going to see him in the 1/2 of the 3/2's coordinate pairs because tangent is sine over cosine. Sine over cosine will only be 1 at one of the ones where they're the same, like pi over 4, negative pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Why would I start only with negative pi over 4? That seems random. Tangent inverse says, look in this quadrant only. Positive pi over 4 is not so good because tangent's positive. Negative pi over 4, booyah. Tangent's -1. Now if it says all values that satisfy, you're like, ah, stink. Where else would it happen? Tangent inverse wouldn't give me any more answers. That's it, that's done. But if it says use that to find all of them, tangent's positive there, he's only negative here. How far apart are they? They're half a circle apart. Sweet, let's just say pi n and be done. Dun, 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 dun. What? Plus 1 pi, plus 2 pi, plus 3 pi, plus 4 pi. Keep adding half circles and you'll keep getting to more and more places where it's true. How do I solve for theta? Yay. So theta equals cosine inverse of 1/2. Where's cosine allowed to be again? 0 to pi? Where's cosine positive 1/2? Well, not him. Pi over 3. You see it? Cosine has to be the little baby one when sine's a really tall one. That's the way we talked about it last year. We can think of 1√3/2 triangle. Anyway. Here. Yay, pi over 3. Cosine inverse only gives you one answer. Aw, stink. Where else is cosine a positive? All students take calculus. Aww.
That's a positive.
They're not a nice, yeah, because cosine goes to the right, remember? So that's a positive cosine, that's a positive cosine. Negative sign, positive cosine. Well, who is he? Negative pi over 3.
Negative 5 pi.
We could go the positive way. We could say 5 pi over 3. Or we could go the negative way and say, hey, it's plus or minus pi over 3. Go up pi over 3 or down pi over 3, plus all of their coterminals. Now, I haven't seen the AP ever ask for the ends, so don't worry about the ends. This is a pre-cal review thing. But remember, inverse trig only finds this one, okay? Inverse trig only finds this one, the principal one. The ones that I found first, negative pi over 4 and pi over 3. And then with our logic, we try to expand that. That's what we did in pre-cal. Okay, that was all pre-cal review. Blah, 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 blah. Let's get back. Very important. So let's get back to calculus, okay? What if I want a derivative of him? I have to think trig and that nasty inverse derivative thing? No, there's a better way. There are formulas. That, to be honest, most of us will just end up memorizing. However, there is an idea behind the formula, and even I learned by looking at your book, it's the proof. I just thought it was like a trick of learning. It's actually the proof of why the derivative formula for sine inverse is who he is. Here's the deal. Do you have a rule to take the derivative of y and the derivative of sine inverse? Any rule for sine inverse of x? No, not yet. We have a forever card with inverse sine. We have a card for inverse of x. We have a card for sine, but we don't have a card for sine inverse. Is that okay?
Obviously, I can't just take the side of both sides.
Yes, we're going there. So since, no, actually just skipped ahead. sense. We don't have a card for sine inverse. Well, how are we supposed to? Oh, take sine of both sides. Take sine of both sides. I have a card for sine, just not sine inverse. Yay, the inverse is gone. Look, so much prettier. If I write it in a pretty way with the little x over here, sine of y. Oh, it's y equals sine of x with the x and y switched. That's what inverses usually do. And then I can say, hey, I can take the derivative of u. U as in u function, not u as in literally the letter u. I can take the derivative of x, which is 1. And I can take the derivative of sine of y. Derivative of sine is cosine. Keep the y times dy dx. So I can say dy dx equals 1 over cosine, and if some of you are thinking that's kind of like the derivative of an inverse formula, 1 over f prime, which is, no, f prime is an division. That is the derivative of sine inverse of x. But you're like, okay, fine. Take the derivative of trig and we get trig, we get it. This isn't a trigonometric answer. No. I see cosine. Me too. It's not trigonometric, it's algebraic. Huh? I see cosine. We're not done. What do you plug into sine? An angle. Oh, hey, for a triangle, why is the angle? Okay. What do we get out of sine? The ratio. Oh, x is opposite over height. Hypotenuse? But x doesn't have an over. Now it does. Okay. So I can label the opposite side and the hypotenuse side. And actually we did this in pre-cal, not this. We just said, hey, find the other side. What would it be like as a formula? Pythagorean theorem, c squared minus a squared. Is b squared square rooted? Hypotenuse squared minus side squared, square rooted is the other side. Okay, fine, you're just showing off now. Wait. Who is cosine of y? Adjacent over hypotenuse. So I can say cosine of y equals adjacent over 1. He's not trigonometric. He's not trigonometric. He's algebraic. The derivative of an inverse trig does not get me another inverse trig. It doesn't get me a trig at all. It gives me an algebraic expression. This whole process is why the formula is what it is, but the formula is what it is. The derivative of sine inverse of x is 1 over, as nasty as it seems, the square root of 1 minus x squared, which comes from a right triangle, which is where sine comes from as well. Now, does your brain just look at that and be like, oh, of course, that makes sense? No. So what's this going to become along with his buddies? His buddies, cosine inverse, tangent inverse, secant inverse, cosecant inverse, and cotangent inverse. A forever card. Maybe there are some patterns that will help us. And there are. You ready? Maybe on Monday or Tuesday, one of those days, technically, if those of you who are going to be gone, if you're not going on the retreat, you should still come to class. Period 1, you are welcome if you want to come and then leave. Or period 6. Sure, why not? We'll just work the system a little bit. Monday is more of a work day. Tuesday is more of a something else. Starting the next section-ish, but really kind of finishing up this section. We're not going to get to as many examples as possible. I'm still going to tape what we're doing unless they're just working on homework. Seniors, it's a busy weekend, right? We wouldn't mind some extra time to do some homework on Mondays. Good. I agree. Okay. We just saw one of these. The derivative of sine inverse of, oh, u, what? Oh, that's right. Whenever there are u's, we just go ahead and use the same formula, but we put in a u instead of an x, and what do we add to the end, cool kids? U prime. Right? So I stole the 1 over square root of 1 minus x squared, but I put a u squared, and I just need a u prime. True? Guess what? Do you guys remember your derivative trig rules, where the derivative of sine was kind of like the derivative of cosine in the sense of how they behaved, just the sign was different? Or the derivative of tangent is kind of similar to the derivative of cotangent, but the sign is different, and they behave in relating different functions, etc. Same thing with cosecant and secant. Guess what's true about the derivative of cosine inverse? Oh my goodness, it's the exact same, but with a negative. Huh? So it's really just one new formula. Just cosine inverse has a negative. Tangent inverse. We didn't get to see a proof of him. I might Monday or Tuesday. Take away the square root, take away the square root, take away the square root. I might try to show you a proof, and I'll tape it for those that are going, as to why it is what it is, but 1 over u squared plus 1 times u prime, or 1 over 1 plus u squared, it can go either way. Guess what? Cotangent, oh my goodness, it's going to be ridiculous and so stinking hard because it's going to be so different and new, and nope, same thing, but with a negative. Same thing, but with a negative. So then last but not least, we have our secant inverse and our cosecant inverse. Now they're a nasty formula, but at least they come in a pair. So it's going to be 1 over, look, they're all 1 over. Absolute value of u, gross, I know, but true. U squared minus 1 backwards of the sine inverse cosine inverse 1 times u prime. My u squared ended up looking like I don't even know what. And cosecant inverse of u, it's going to be the exact same thing, but with a negative. It's ugly, but it's true. Guess what this whole page is going to be? Forever, remember. 17.
Wait, Misty, is that a minus or a times?
Minus. Times u prime. Okay, so this is ridiculous and it's super hard and there's no way we could possibly do it. No, we just memorize the formula and we use, not that one. Ah! We memorize the formula and we use it. Huh? We say, focus. In a few more seconds, let me get a little further than period 1 because we started ahead. The derivative of sine inverse of u is 1 over the square root of 1 minus u squared times u prime. Now that's right, but he's hard to simplify. He's right, but he's hard to simplify. So, Monday/Tuesday, somewhere in there, seniors and I are going to be going through examples. I'm going to be taping it. I'll be like an online tutor. You can watch later. Anybody who's not going to be here. Homework is due Wednesday, as much as is possible. But Wednesday in class, we will not finish the next section, so we can pretend like it's Thursday. But juniors, sophomores, and anyone below, you can come to school. If you're not going to retreat, please do. If you're going to retreat, please enjoy the work you have a little bit first. But you can do 13 all the way. 14, you might need to wait a little bit.
Oh, I'm still there. Okay, cool. Because my grade is. Oh no, my grade is not there.
Monday night, after more examples in class. Just 13.
Thank you, Jeremy. Oh, there he is.
What?
He's still here in the road. Why no? I was kind of asked why didn't you go to the lunch thing, and I was like, all right, Chick-fil-A. No. Really?
Coming soon to a math classroom near you.